So, very good afternoon to all. Okay. So today we are going to see our subject practicals. Okay. In the last practical, that is before the Diwali vacation, we have seen one first practice, that is the ISO standard symbols of our fluid power. Okay. Still some symbols are remaining. We explain that. But today we are going to see some virtual lab experiment. Okay, so I will start with some basic point. Okay, now see, now you are at your end, that means at your home. Okay, and I am at this college. Okay, now if you see the practicals, then you need to be here. Okay, while performing, or you have to perform the practical. Okay, physically at this lab. Okay, but due to this pandemic situation, it is not possible to you all to come here, okay, and to perform some practicals. So for this problem, there is one solution, that is a virtual lab practicals. Okay, so you know that in our this country we have the IITs, NITs, and some reputed institutes. Getting it? IIT Bombay or IIT Kharagpur, IIT Roorkee, okay, NITs. That means the reputed government institutes. Okay, our COP also. They have what they have done. They have introduced one concept, that is a virtual lab practical. Okay, that means whatever practicals we are performing we want to perform in the lab, that practical they are performing virtually. Okay, virtually they are performing. That means we are following, for example, suppose first my experiment is for as per our syllabus. Okay, we have just case studies, that means assignment oriented. We have the practicals. Okay, and then we have some demonstration practicals also. Okay, now here I will take one example. Okay, for example, if our practical will be like that, identify various components of a control valves. Okay, identify the various components of the control valves. Okay, then if you were if for example, if you will be here, then what you will do, you will write, or you will come to know that aim of the practical, then it's a theory. Okay, that process to follow that practical, or to perform that practical, we should know the procedure. Okay, then we are taking some readings, general points I am telling about the any practical. While performing the any practical, which steps, which process we have to follow, that we know that. So same procedure we have to follow for this virtual practicals also. Okay, virtual lab practicals. Okay, virtual practical virtual practical means what? कॉम्प्युटरवर व्हर्च्युअली आपल्याला प्रॅक्टिकल परफॉर्म करायचे, सेम प्रोसेस वगैरे आपण फॉलो करायचे, आपण त्याची थेअरी बघायचे, एम काय आहे, नंतर थेअरी काय आहे, त्यानंतर कसं प्रॅक्टिकल स्टेप्स काय आहेत ते बघायचे, त्यानंतर रीडिंग. फॉर एक्झाम्पल आपण काय ते इनपुट देतो बघा, कुठल्या प्रॅक्टिकलला इनपुट जर दिलं तर आपल्याला काय आउटपुट भेटतं, तर इनपुट काय द्यायचं दिलं पाहिजे ते सुद्धा आपण बघणार आहे, आणि आपल्याला रिझल्ट म्हणजे काय, आपलं आउटपुट काय भेटेल ते सुद्धा आपण बघणार आहे. गेटिंग इट? ओके, so we have to see the virtually we have to perform the practical. Getting it? Okay, समजला मी काय म्हणाल, समजलं का? I will ask one student, ऋषिकेश देशमुख, व्हर्च्युअल प्रॅक्टिकल म्हणजे कळलं का? रोहन पांढरे, शिवानी, निकिता पवार, नेहा पाटील, ज्ञानेश्वर, सचिन. व्हर्च्युअल प्रॅक्टिकल कळाला म्हणजे नक्की काय असतं? तुम्हाला म्हणजे व्हर्च्युअल प्रॅक्टिकल समजलं तरच आपल्याला कसं परफॉर्म करायचं, काय कुठलं प्रॅक्टिकल आपण ते स्टार्ट करू. मग आणि राहायला महत्वाचा भाग की आपला पहिला चॅप्टर नेमच्या वर झालेला आहे, थोडं आपण अजून जस्ट पहिलाच कॉम्पोनंट जस्ट स्टार्ट केलाय दॅट इज ऍक्च्युएटर. ओके, यू नो द डेफिनेशन और द जस्ट वर्किंग प्रिन्सिपल ऑफ द ऍक्च्युएटर और यू नो द फंक्शन इन डिटेल वी आर सीइंग दॅट ऑल्सो. आपल्याला फ्लुइड पॉवर म्हणजे काय, हायड्रोलिक म्हणजे काय, न्यूमॅटिक म्हणजे काय ते आपल्याला माहित झालंय, त्यांचं ऍप्लिकेशन माहित झालंय, बेसिक कॉम्पोनंट्स कुठले हायड्रोलिक सिस्टमचे किंवा न्यूमॅटिक सिस्टमचे ते आपण बघितलेले. आपल्याला क्लिअर आहे की आता न्यूमॅटिक हायड्रोलिक म्हणजे काय, न्यूमॅटिक. ओके, जस्ट आय विल आस्क सम बेसिक क्वेश्चन. हा, सुजित माने, हायड्रोलिक्स चं फंक्शन काय, की हायड्रोलिक्स कधी म्हणायचे सांगा बरं, हायड्रोलिक्स कशाला म्हणायचं? सुजित माने, गौरव खंडेलकर, बालाजी पिसे. कुणाला ज्यांना आन्सर येते त्यांनी सांगा. आपण हायड्रोलिक्स कशाला म्हणायचं आणि न्यूमॅटिक कशाला म्हणायचं? की जस्ट टेल मी द बेसिक डेफिनेशन ऑफ द हायड्रोलिक्स और फंक्शन ऑफ हायड्रोलिक्स. कुणीही सांगा. एनीबॉडी कॅन गिव्ह द आन्सर. Just I am taking the recap, okay, or just a revision what we studied in the theory part. About that I am just asking. कोणी तर सांगा. राहुल गायकवाड, हायड्रोलिक कशाला म्हणतो आपण आणि न्यूमॅटिक कशाला म्हणतो तेवढं सांगा फक्त. गौरव कारंडे, बालाजी पिसे, प्रमोद, अभिजित, ऋतुजा कापसे, ओंकार सरडे.
हायड्रोलिक मध्ये सर ऑइलचा यूज करून प्रेशर क्रिएट करून वर्क डन केलं जातं आणि न्यूमॅटिक मध्ये एअरचा यूज करून वर्क डन केलं जातं.
एअर म्हणजे हा, ओके, म्हणजे इफ वी आर युजिंग लिक्विड, ओके, दॅट मीन्स द हायड्रोलिक एनर्जी मीन्स व्हाट, लिक्विड. फॉर एक्झाम्पल, इफ यू आर युजिंग द लिक्विड and that liquid's pressure if we use for perform the any type of work, that time, so in simple word, that time we can call it as a hydraulic. Okay, conversion of energy, fluid energy is converted into the mechanical work means what, mechanical energy. Okay, fluid energy. Now in that fluid, if you are using liquid, that time you can call it as a hydraulic, and if you are using any compressed air or the gases, okay, to perform the work, that time you can call it as a pneumatic. That is a simple difference. Okay, and we have seen that basic components of the hydraulic system and pneumatic system also. Okay, in the hydraulic system we need pump, getting it, to store the that excess fluid. We need the accumulator, reservoir म्हणतो आपण त्याला. Then we need to if we need to increase the pressure of the fluid, the intensifier or booster is one unit. Okay, intensifier is there. Then to convert the fluid energy into the mechanical energy, we need the one important element or component, that is the actuator. Fluid energy into the mechanical energy. Okay, that pressure energy you can call. आणि न्यूमॅटिक सिस्टम मध्ये काय लागतो आपल्याला, पंपची गरज नाही, कॉम्प्रेसरची गरज आहे. वी आर टेकिंग द एअर फ्रॉम द आउटसाइड एन्व्हायरमेंट सराउंडिंग. Okay, and that air we are filtering with the help of the dry air and the filter unit, FRL unit also. Okay, and by using the compressor we are compressing that air, and that pressurized or compressed air we are using for the doing the some work. Okay, that means pump is required in the hydraulic hydraulic system, and the compressor is required in the pneumatic system. Other parts are the similar, same for the both the system. Getting it? आता in the last lecture, okay, आपण काय बघितलं, ऍक्च्युएटर चालू केलं होतं बा, ऍक्च्युएटर थोडं बघितलं, त्याचं क्लासिफिकेशन बघितलं. ओके, आणि आपण मोटर्स पण चालू केलं, म्हणजे रोटरी hydraulic actuator. We have started last lecture. Okay, and linear असेल तर आपण त्याला सिलेंडर्स म्हणतो, हायड्रोलिक सिलेंडर. म्हणजे बेस्ड ऑन द मोशन you get at the output of the actuator, depend on that we have classified the actuators. Getting it? आता that was the आपला थिअरीचा पार्ट झाला. आपण प्रॅक्टिकल मध्ये लास्ट एक प्रॅक्टिकल मध्ये आपण बघितलं होतं की आपले जे हायड्रोलिक सिस्टम असू द्या किंवा नोमॅटिक सिस्टम, ओके, इन द बोथ द केसेस while designing any system, it is not possible to draw the actual image of the any component. So instead of the taking the actual image, what we are doing, we are representing that component of the element by using the ISO standard symbol. प्रत्येक component चा एक, let it be small pipe असू द्या किंवा तुमचा actuator असू द्या, सिलेंडर असू द्या, ओके, किंवा वॉल असू द्या, प्रत्येक याला सिम्बॉल आहेत आपल्याकडे आणि विथ द हेल्प ऑफ दॅट सिम्बॉल्स वी आर रिप्रेझेंटिंग दॅट होल सिस्टीम. गेटिंग इट? आता पूर्ण हायड्रोलिक सिस्टम असू द्या किंवा नोमॅटिक सिस्टम, ओके, तर ते आपल्याला रिप्रेझेंट करायचं त्यात सिम्बॉल्स आपण टाकून जातो आणि ते एक आपल्याला पूर्ण सिस्टम तयार होते बा. ते जे आहे त्याला आपल्याला म्हणायचं फ्लुइड पॉवर सर्किट, सर्किट डायग्राम म्हणा त्याला. डिझाईनला जे आहे डिझाईन जे तयार करणार आपण त्याला म्हणायचं सर्किट डायग्राम. गेटिंग इट? आता now we come to know that virtual lab means what and its experiment. तर आपण काय करणार आहे for in today's lecture or today's practical, okay, we are going to see the virtual experiments. Okay, how virtually we can conduct any experiment that we are going to see for this today's practical. And for this today's our practical, we are going to see the some basic practicals about the pneumatic. Okay, hydraulic असलं किंवा pneumatic काय फरक पडत नाही. जस्ट if you change the medium, liquid to air or liquid to gas, pneumatic system will start. Okay, लिक्विड असेल तर हायड्रोलिक सिस्टम म्हणायचं, एअर असेल किंवा गॅस असेल तर pneumatic सिस्टम. वॉल जे आहेत, ओके, कंट्रोल वॉल म्हणजे काय, प्रेशर कंट्रोल वॉल, तुमचा फ्लो कंट्रोल वॉल आहे, डिरेक्शन कंट्रोल, ते वॉल सगळ्याला म्हणजे हायड्रोलिक्स मध्ये पण सिस्टम मध्ये तेच वापरणार आहे, न्यूमॅटिक सिस्टम नुसार. फक्त काय तर मीडियम, फ्लुइड मीडियम फक्त चेंज आहे. ओके, तर वन बाय वन आपण व्हर्च्युअल लॅबच्या एक्सपेरिमेंटला चालू करू. ओके, गेटिंग इट? हा, समजतंय ना? Now today we are going to see the first practical. Will take this one. Okay, identify various components of a pneumatically operated controller. Okay, pneumatically controlled wall. Whatever the practicals in the virtual lab experiments we are going to see now. So all the practicals or these experiments are available in the website of the virtual lab. Okay, virtual lab. In that again, virtual lab means what? Okay, I will show that also. If you search on Google now, just see virtual lab. Okay, I'll पहिली window. So our Minister of Education, okay, under the National Mission on Education through ICT, they have developed this virtual lab. Now in this virtual lab, okay, or for the development of this virtual lab, no, the reputed institute of our, okay, see, our India's reputed institute is what? IIT Delhi, IIT Guwahati, IIT Roorkee, IIT Kharagpur, IIT Bombay, IIT Kanpur, IIT Hyderabad. These are the some institute. They are helped or they are supported, okay, for this development of virtual lab. Okay, and on this platform we have all branches virtual experiments. Okay, see, electronics and communication, computer science, mechanical is there. Okay, if you click on that mechanical, I will show this the platform. See, by clicking on a mechanical you will get the different labs. See, virtual aerospace engineering is there, mechanics and robotics is there. Then I will show another, and which lab who has developed that also, its name also they have mentioned. See, IIT Kanpur, Kharagpur, okay, like that. See, vibration is there, micro machining is there, machines of mechanic mechanics of machine is there. Again, we have the few more labs. Okay, see, virtual combustion and automation lab is there. Automation, 3D printing is there, mechanical fluid and thermal sciences lab is there. If you click, I will click on this. See, it will redirect to the that institute's virtual lab website. See, we have the another this experiment. See, I think you have seen that FMFM practicals also, energy losses in the pipe, flow through the vector meter. Okay, I think this practicals you have seen. Okay, so like that, our government has taken the initiative, and they have developed these types of the virtual experiments or virtual labs. Okay, with the help of reputed institutes of our India. Getting it? And these all labs experiments are free, available to everyone. Okay, so you should know this free resource for your betterment or for your development. For that purpose, we are taking the virtual lab practicals. Getting it? Okay. Why we are taking the virtual lab practicals? Okay, it's answer I have. Getting it? Now, come to the point. Okay, so firstly today we are going to see this first practical. Okay, so here I in this Google sheet I have just pasted the it's a link also. Okay, for example, if I want to see the practical virtual lab practical of the this identify various components of a pneumatically operated control, then it's a link I have given. I will click on that this. You can also just Google search on Google, you will get the all practicals. Okay, just I have extracted the practicals which are relevant or which are related to our subject, that is hydraulics and pneumatic, that I have taken. Okay, and I got the virtual lab experiments related to our subject. Okay, now see whether screen is visible at your end. स्क्रीन दिसते का व्यवस्थित सगळ्यांना?
येस सर.
कुठे अजून मोठी करतो मी. ओके, आय थिंक 125% झूम इज सफिशियंट. ओके, आता दिसते ना? So today we are going to see the first practical, that is identify various this identify various components of the pneumatically operated control valve. Okay, so in this practical, okay, for this practical, what contents we are going to see, that we should know. So you can see the left hand side. Okay, this aim is the given. Okay, we have to see the aim. So right now, where are this aim part? Our aim of this experiment is to identify various components of a pneumatically operated control valve. Getting it? After aim, we are going to see the theory part. Theory also given. If you don't know anything, then also no problem, because theory given, they have given the theory part. Okay, so don't stuck on that one point that yet we have not seen the control valves and how we should go for direct practical, because in the practical we have to see the practicals, so it is not possible to perform the physical practicals. So we are taking the virtual practicals, and everything is available. Okay, so theory also we are going to see. Okay, then after studying that theory, some pre-test, some MCQ based questions are there. Okay, that we can see, and after that, to how to perform the practical, its procedure also given here. Okay, and after procedure, you have to follow the our performance of this practical. So for that purpose, this simulation part is given. See, okay, and after simulation means what? You have to give the input. Whenever we are giving some input to the any part, definitely we will get something as an output. Getting it? Okay, that result. And then after studying this entire practical, after performing this practical, again we have this poster testers. Poster test, and at last they have given some references also. That means for this practical, from where they have taken the data, or if we need any more information that purpose, they have given the references. Getting it? Now let us go for our practical. Now our practical name is identify various components of a pneumatically operated control valve, and our aim is same: identify various components. We have to identify, just we have to identify. Actually, this is a theoretic practical, but virtually we have this. We have to identify practical components. Okay, we have to identify the practical components of whom of a pneumatically operated control valve. Okay, now let us go for it's the first part, that is theory. We should know all theory about this. Are you getting whether it is interesting or not? Interested आहे का नाही आहे? Whether it is interesting?
Yes, sir.
Okay. Now, जर कोणी पहिले अगोदरचे आपले लेक्चर अटेंड केले नसेल, तरी सुद्धा त्यांच्यासाठी सुद्धा हे डिरेक्टली लगेच समजून जाय. ओके, डोंट वरी, बिकॉज थिअरी सुद्धा त्यांनी कसं आपल्या एकदम साध्या सिंपल वर्ड्स मध्ये सांगितलेले. ओके, आय एम गोइंग टू रीड दॅट ऑल्सो अँड आय एम गोइंग टू एक्सप्लेन दॅट ऑल्सो. ओके, सिंपल लँग्वेज मध्ये सांगितले, त्यामुळे थिअरी शिकलं तर आपल्याला ते फ्री टेस्ट द्यायला सोपं पडून जाईल. आणि थिअरी जर आपल्याला माहित असेल तर आपल्याला प्रॅक्टिकल परफॉर्म करायला सोपं होऊन जाईल. त्यासाठी मग आपल्याला प्रोसिजर दिलेले आहे. ओके, वी हॅव टू जस्ट फॉलो द इन्स्ट्रक्शन. ओके, आपल्याला नवीन काहीच करायचं नाही. वी हॅव टू जस्ट फॉलो द प्रोसिजर. Okay, just I want to ask one small question: whether this speaking speed or teaching speed is fast or slow, or it is moderate? Whether it is okay to you all, or may I increase my speed, or may I slow down my speed? बोलत राहा. येस नो काय तर म्हणा, किंवा तुम्ही अनम्यूट करून सुद्धा बोलू शकता. माझं टीचिंगचं स्पीड एकदम ओके आहे का? फास्ट बोलतोय मी? कसं आहे, क्लासमध्ये फिजिकल असेल तर कसं मी जे बोलतो ते लगेच तुम्हाला कळत असेल पडदेशी. पण आता फिजिकली मी करतो, माझ्याकडे फॉर एक्झाम्पल इंटरनेट स्पीड चांगला आहे म्हणून मला काय जाणवत नाही, एकदम ओके. पण तुमच्याकडे इंटरनेट स्पीड कमी असेल तर काय होणार, आवाज अधून मधून काय होणार, कट होऊन जाणार. ओके, असं पण कधी कधी थोडंफार प्रॉब्लेम येतात, म्हणून मी विचारतो. ओके, कधी कधी कसं होतं, माझं टीचिंग स्पीड सुद्धा फास्ट होऊन जाते, असं वगैरे काय आहे का? आणि महत्वाचं काय झालंय की here itself I want to put one small thing I want to clear. In the before the last week I was teaching the another subject, that is non-question busting. Okay, and in the last before the Diwali we have started our industrial hydraulics and pneumatic subject, this one. So some students have attended some lectures of the another subject teacher Dawade sir. Okay, now you are learning this subject from me. Okay, so maybe some comparison may happen. Okay, तसं पण होऊ शकतं. ओके, तसं थोडं मला थोडं सांगा जावं की सर हे रिपीट करा किंवा स्पीड कमी करा, जास्त मोर एक्सप्रेशन. ओके, may I go for next? That means our main point, that is theory. theory ला जाऊ द्या का?
Yes, sir.
I will ask you one. Bapendra Sondakke. Sondakke, roll number 44.
Yes, sir.
Okay. Thank you. Now see the theory. Our aim is to identify the basic components of pneumatically operated control valve. Okay. Now I will read the theory also. I will explain. So what is mean by the control valve that we should know? So a control valve is a final control element and power operated device. Control valve is the final operated element and power operated device which is used to control the flow of fluid. Okay, which is in the name itself, everything is clear. Control valve to control. Okay, what to control? Flow of the to control the flow of the fluid. Okay, or if you want now, if that walls are pressure control valve, then that means that wall is controlling the pressure. If it is a flow control valve, that means that control valve is controlling the flow of the fluid. If it is pressure control valve, if it is direction control valve, that means that wall is controlling the direction. Every wall having its own function. Okay, so a control valve is a final control element and it is a power operated device which is used to control the flow of fluid. To control the flow of fluid. Okay, in a process that system. Okay, whatever our system, it is in process now that where that need to control. So at various degrees between minimum flow and full capacity. Okay, in response to the your signal, whatever the signal means, what from actuator you will get a signal. Okay, reduce the temperature, reduce the flow, or the reduce the pressure, or change the direction. That signal will get from the our main part, that is actuator. So whenever we'll get the signal from the controlling unit, that time you can control the flow of the fluid, you can control the direction, you can control the that pressure. Okay, so these are that is mean the control valve. Now this control valve can be operated or operated using pneumatic, electric, and hydraulic signal. Okay, see, control valve can be operated using pneumatic, hydraulic, and electrical signals. Okay, if you will get the signal from hydraulic means what? You will get from the signal from actuator. In same way, in the pneumatic system also, you will get a signal from the actuator only. Okay, because actuator is the end element of the your system. Okay, from where you will get the output. Okay, so now that this is a control valve, definition of the control valve. Okay, once again I am repeating, control valve, this part. Okay, it's a theory, that classification, unit working principle, everything we are going to learn in the unit number 2 for hydraulic and unit number 5 for pneumatic. Okay, walls are same for both the section. Okay, but here as a theory, we should know the basic, we should know the it's a definition. For that purpose, I have just explained. Control valve is a final control element and it is a power operated device. Okay, which is used to control the flow of fluid or the pressure of the fluid or the direction of the fluid. Okay, in process system that. Okay, at various degree. Okay, whenever you will get the response to your signal from the controlling system. Okay, now our experiment to identify the components. That means we should know the component. Getting it? So you can see our control valve having the basic components as follow. Control valve basic components are as follow. Which are the basic components of the control valve? So first is the body. Body is the first component of the element of the your valve. Then bonnet, then stem. Okay, in for which part we have to call body, bonnet, stem, that we are going to see. Okay, then actuator. Actuator also is the important point of the control valve. Then disc and seat. So these are the 6 basic elements or components of the control valve. Now In detail, we will discuss this one. To whom we should call body, that we should know. So body means what? The body, sometimes it is also called shell. Okay, and this body is the primary pressure boundary of your wall. It is a primary pressure boundary of your wall. Okay, and it serves as a principal element of your wall assembly. It serves a principal element of a wall assembly. Why it is serves as a, or how it is principal element of a wall body? Because it is a framework. Body means what? Is a framework that holds everything together. That holds everything together. And wall bodies are wall bodies are cast or forged into the variety of shape. Okay, how they are manufacturing this wall body? The wall bodies are normally it is a manufactured using the forging operation or the casting operation. Okay, into the variety of the shapes and the size. Okay, depending on the requirement. And although your sphere or the cylinder, okay, would theoretically be the most economical shape. Okay, the wall shape commonly spherical or the cylindrical is used. Okay, that is the most economical shape. For what purpose? To register fluid pressure when a wall is open. Okay, when wall is open, that time that sphere or the cylindrical shape. Okay, it is to that shape. It is very easy to register fluid pressure. Okay, when that wall is open. Okay, and there are many other considerations also along with that. Okay, getting it? Sphere shapeचा आणि cylinder shapeचा normally आपण बॉडीचा शेप असतो. Okay, that is a body. Then bonnet, to whom we should call bonnet of the wall, that we will see. The bonnet. Okay, so the cover of the opening in the wall body, you know. Okay, the cover for the opening in the wall body. What is the cover? Cover the opening. Cover for the opening. Cover for the opening in the wall body. Okay, is the bonnet. Who knows what bonnet? And the upper part of the wall body, that is usually separately or separable. Okay, upper part of the wall body, it is separable. Okay, you can take out. Okay, and normally it is contains the wall stem, seal, and guides. Okay, wall stem and guides. And in some designs, the body itself is a split. Okay, body itself is a split into two sections. That means the your body can disassemble into two parts. Okay, and normally that body is combined with the help of the bolt together. Okay, so like your wall bodies, bonnet, okay, they also vary in the design. Okay, and the bonnet is the second principal pressure boundary of your wall. Okay, your bonnet is a second principal pressure boundary of your wall, and it is also cast product, or it is also forged component of the same material as the body. What are the material used for the wall body? The same material need to use for the bonnet, and normally it is connected to the body by the threaded or the bolted or the weld joint. Okay, बॉडीला ते कसं कनेक्ट केलं जातं? तर तुम्ही नट बोल्ट वापरा, थ्रेड करून करा का वेल्ड करा. And in all cases, the attachment of your bonnet to your body is considered a pressure boundary. Please remember, the attachment of the bonnet to the body is considered the pressure boundary. Okay, and this means what? The weld joint or the bolt joint connect your bonnet to your body. Okay, actually this bonnet is a complicated part to manufacturing. Okay, then stem means what? The stem which connect the actuator and your disc or the plug. Okay, and it is responsible for positioning that your disc. Okay, and normally stem are typically forged and forged component, and it is connected to the disc by threaded or by welded joint. Okay, for wall design requiring the stem packing or the sealing. Okay, that is requirement. Okay, after stem we have the disc or the plug. Okay, to whom we should call plug. Plug is a part of the wall that is positioned in the flow part of path to the to modify rate of flow through the pipe. Okay, plug is the part of the wall that is positioned in the flow path to modify rate of flow through the pipe. And for a wall having the bonnet, this plug or disc is the third principal, the primary principal pressure boundary. Okay, and this disc provides the capability for permitting and prohibiting the your flow fluid. Okay, or fluid flow. Normally, this with disc closed, full system pressure is applied across the disc if the outlet size is pressurized. Sorry, depressurized. Then we have the another element that is this one seat. Now seat means what? It is also named as a sill rings. Okay, it provides the sitting surface for your disc. Okay, and in some design, your body is machined to serve as a sitting surface, and sill rings are not used. Okay, in some cases, actually that body itself is machined to serve the sitting surface also. So that time it is no need to go for the separate sitting arrangement. And in other designs, the forged sill rings are threaded or the welded to your body to provide the sitting surface. Getting it? And the last and important element that is actuator. That is a actuator, wall actuator. Huh? So the actuator operates the steam. This is not your actuator, that cylinder and motor. Okay, in your control wall, when we have the wall actuator. Okay, so that actual operate your steam and disc assembly. Okay, operate your steam and your disc assembly. And this actuator may be manually operated by the hand wheel or the manual lever or a motor operated. Okay, or it may be operated by the solenoid operator or pneumatic operator or the hydraulic ram also. Wall. And in some designs, the actuator is supported by the bonnet. Okay, and in other designs, your yoke mounted to the bonnet that supports your actuator. Okay, so these are the components. Getting it? This is a theory. I think we should quickly. I will show this. Let me check. I will show one small video about the wall. Okay, so that it is easy to understand. Okay, one small video I will show. One control wall I will show. Okay, there are many types of animation. Sorry, walls. Okay, but we'll see the. I will show this one. How pneumatic control wall works. Okay, control wall. Is it okay to have the video? Okay, at this point. थेरी नंतर एखादा व्हिडिओ. ओके, हे आपण इंडियन थेरी मध्ये बघणार आहे बरं का, आपलं जे टाइमला लेक्चर असतं त्या टाइम बघणार आहे. पण आता आपण कसं की आयडेंटिफाय करतो की वॉलचं वेगवेगळं कॉम्पोनंट. ओके, कंट्रोल वॉल जे आहेत ना, which are operated by pneumatically, it's a component we have to identify. For that purpose, just in the theory part, we have seen that which are the component to whom we should call bonnet, body, wall, actuator, steam, or plug. Okay, so we'll see this one video how pneumatic control wall. Actually, this is a whole system. See, now these are the final control elements. Pump motor, See, heater is there and control wall. Okay, see the control wall. And in this practical, we are concentrating on this one, control wall, third element. Getting it? And how control wall exactly works, that we have to see. What is a control wall and how does it work? See. Slip. See, fluid is coming and to control its direction. See, that is a throttling. So, what is that throttling of the fluid? We don't need to go for that throttling. Video we are seeing now, watching. That is a globe wall. That is the body. See, that is the body. One minute. See, positioner. हायड्रॉलिक किंवा न्यूमॅटिक सिस्टीमचा हा वॉल हा एक एलिमेंट आहे, कंपाऊंड आहे. त्या एलिमेंट मध्ये आपल्याला वेगळं ग्लोब वॉल मध्ये कुठलं कॉम्पोनंट म्हणजे कुठल्या कॉम्पोनंटला कुठल्या भागाला काय नाव आहे बघा. सी बॉडी. आता दिसलं का बॉडी कशाला म्हणायचं, बॉनेट कशाला म्हणायचं, प्लग कुठे प्लग कंट्रोल ऍट टॉप. सी देन स्टेम. ऍक्च्युएटर कुठे आहे बघा, प्लगच्या खाली ऍक्च्युएटर आहे. कळलं? बॉडी, बॉनेट, प्लग, ऍक्च्युएटर, स्टेम. ओके, सो these are the and the plugs. Okay, these are the 5 main elements. Getting? So these are the 6 elements or the components of the control wall. Okay, now let us go for the pre-test. Whatever we have seen the theory, based on that we have the tester. Okay, I will read just a question. You just Okay, sorry to interruption. Okay. So I was talking about this pretest. So regardless of the type, all walls have the following basic parts with the exception of following options: bonnet, nipple, actuator, body. Out of these four, which is a not part of wall? Tell me which part is not part of wall. Tell me the option A, B, C, D. Just in the chat box also you can write your answer or tell me. अनम्यूट करा आणि बोला काय हरकत नाही. दिलेल्या चार ऑप्शन मधला कुठला पार्ट हा वॉल मध्ये येत नाही? All walls having the following basic parts with the exception of whether bonnet is a part of basic part of the wall. Yes. Whether actuator is a part of basic part of wall. Yes. Body. Yes. Nipple is a not part of the wall, basic part of wall. Okay, so answer is nipple. Then next question number 2. The body of a wall typically receive inlet and outlet piping through the any of the following type of joint except. Please read. जे आपण थिअरी आता बघितले त्याच्यावर क्वेश्चन आहेत. ओके, नथिंग मोर देन दॅट. The body of a wall typically receives inlet and outlet piping through any of the following type of joint except. Okay, कुठल्या प्रकारचा जॉइंट असतो? वेल्डेड जॉइंट होता, आपण बघितले. बोल्टेड पण चालतोय जॉइंट, थ्रेडेड पण चालतोय, ग्लूड नाही. ओके, सो दिस इज द ऑप्शन except. Okay, following this glue type of joint, it is not for this body of wall. Then the internal elements of a wall. The internal elements of a wall are collectively referred to as walls. Internal elements of the wall are collectively referred to as a walls. Okay, guts, stream, verse, or packing. Packing is answer correct, I think. Okay, the manually operated hand wheel, manual lever, motor operated, solenoid operator, pneumatic operator, or hydraulic ram are all examples of actuator. Okay, sorry, the manually operated hand wheel are all just just see that. Actuator operates. This statement is important. Actuator may be manually operated. Okay, this that means our answer is actuator is correct. Okay, and last one, which one of the following wall part is not usually considered to be part of the pressure body? Okay, which one of the following wall parts is not usually considered to be part of the pressure body? I think pressure boundary. I think body. Okay, just we'll see. 3 out. Body is wrong answer. And this one, packing. I think fair. We'll see. Internal element of wall. We'll see that also. seat ring. Okay, seat ring is not a part of the pressure boundary. Okay, and this I think verse is the correct answer. Sorry, stream. Okay, this part I think we have not. I have not explained. Okay, so this was just a pre-test. What we have seen the theory based on that test was there. Now, procedure to follow this to perform this experiment that we will see. So what is the procedure to perform this experiment? So first step is identify the components of the library, then drag and place it accordingly. Okay, identify the component. First, we have to identify the component from the library. Then we have to drag and place it accordingly. Okay, we have to place it accordingly. Then do the same procedure for all component. Okay, then click on the identify button. Okay, firstly सगळे component आपल्याला आयडेंटिफाय करायचे आणि त्या जागेला ते आपल्याला ठेवावं लागणार आहे. Okay, we have to take from the library and we have to place it accordingly. Then we have to click on the identify button if components are placed at correct position. See, if components are placed at correct position, then you will get message all components are placed correctly. See, okay, if we have placed all components, if we have identified all components correctly and if we have placed all components correctly, okay, then placed correctly, and if not, you will get the message components are placed wrongly. Okay, then after identifying button, we need to perform experiment again. Click on the reset button. Okay, if we got the message or if we get the message like that components are placed wrongly, that means we have to reset and we have to go for once again. Okay, and we have to check. This is a simple procedure. Just say simulation. We have to track the component. Now here we'll see the first body, wall body. I will take. Sorry, we have to give the name. Okay. These are the different parts. Okay, we have to give the names. Tell me the name of this. काय असेल हो हे? काय असेल? Whether it is spring or positional steam or actuator steam or actuator or glad packing or indicate seed ring or plug. काय असेल हो? Okay, just guess. काय असेल सांगा. अंदाज सांगा. We'll go for sure. I think from this, okay, from this fluid, from this direction fluid is coming, it is going like that. Okay, so this is a positional stem will take. Okay, this will take as a gland packing. Sorry, still ring you will get it. Then this one, this is your plug. Okay, then this is your packing bonnet wall body. Indicate plate. Your spring. I will give name me wall body. Okay, and then this is stem, actually stem. This is the gland packing will take. This is a bonnet I will take. This is the actuator I will consider. I will consider as an actuator. Okay. See. And after now, I think some parts maybe I have taken wrongly. Okay, we'll just see how on. After this, after choosing or after dragging all the parts, we have to identify. So I will click on this identify. Please select the remaining elements. I think which is remaining. Where are they? Is there anything remaining? Oh, sorry, another more. One second, I will. See the remaining element. We have taken all the elements. What is remaining? What is the remaining? Please select the remaining elements. Let us see that. Okay, let it be. So this like this, we have to follow the procedure. Okay, and after submitting, okay, you will get the here at a result. Will get the that message. Okay, you have chosen the all the elements correctly, and if it is wrong, then like that we'll get the message. Okay, if we got the message like that you have chosen the wrong element, then we have to reset that simulation and we have to perform the once again. Okay, so this that is a procedure. And after completion of the experiments, we have to go for the post test also. Okay, that means this. Okay, so this is a procedure for this identify this experiment, that is identify various components of a pneumatically operated controller. Getting it? Now let us go for one more experiment. Okay. We'll go for this one. size and select a pneumatically operated control valve for a particular application. Okay, 1 minute. Okay, so here just I will we'll go for this one. I will just select pneumatic cylinder for a given load. Now, for a given load and speed requirement. Okay. Now, as we know that okay, so we have to select the pneumatic cylinder for what purpose? For given load and speed requirement. Okay. See, we have to select the pneumatic cylinder for given load and speed requirements. And its aim is design and develop a pneumatic circuit to operate single acting cylinder for specific load and speed. Let us discuss the theory part also. Okay, quickly I will go. I will not take more time for this. Okay, because this part we are going to see in theory. Now, the basic question arises is that what is meant by pneumatic cylinders? So, pneumatic cylinders are devices for converting the air pressure into your linear mechanical force. That means fluid energy into the mechanical energy. Okay, air pressure is converted into the linear mechanical force and motion. Okay, so that is the main function of the pneumatic cylinder. And based on the cylinder action, we can classify the cylinder as a single acting and double acting. Please remember, based on the cylinder action, we can classify the cylinders as single acting and double acting. Okay, single acting cylinders have single air inlet line. Single acting cylinder have single air inlet line. Okay, just remember. And this single acting cylinder have one working port. Okay, see, one working port, pressure port you can see. And forward motion of the piston is obtained by supplying compressed air to this working port. Okay, we have to supply we have to supply the compressed air to this working port. Okay, because as we know that in the single acting cylinder only one working port is there, and to get the forward motion of the piston, we have to supply compressed air to this port. Okay, through this port. Okay, if we see, if we apply the fluid, or if you supply the fluid through this working port here, then it will apply the pressure, or it will give the forward motion like this. Okay, it will. Okay, and return motion of the piston is obtained is obtained by spring. Okay, by this spring, return motion is applied. Okay, that means back to. Okay, when firstly you are applying the pressure motion by supplying the fluid. Okay, इथं काय करतो आपण पहिल्यांदा या प्रेशर पोर्ट जे आहे ना ते वर्किंग पोर्ट तिथून फ्लुइड आत पाठवतो आपण. फ्लुइड आत गेल्यानंतर काय होणार आहे हो, त्या कॉम्प्रेस्ड एअर मुळे त्या पिस्टन सील पिस्टन दिसतंय तर त्या पिस्टन वर काय होणार, प्रेशर अप्लाय होणार आणि प्रेशर अप्लाय झाल्यानंतर यू विल गेट द मोशन टू द युअर पिस्टन अँड आफ्टर गेटिंग अ मोशन तर दिस पिस्टन विल मूव्ह टू दिस पॉइंट इकडे. ओके, आणि इथं आल्यानंतर काय होणार होते तुमचं सगळं फ्लुइड ह्या वेंट जी दिसते ना वेंट मधनं ते बाहेर पडणार. ओके, आणि मग फ्लुइड ज्या टायमाला इथं बाहेर पडेल वेंट मधून त्या टायमाला काय होणार, पुन्हा तुमचं पिस्टन तुमच्या ओरिजिनल प्लेसला यासाठी असेल तर तिकडून सेपरेट पुन्हा फ्लुइडची द्यायची गरज नाही. का द्यायची गरज नाही तर स्प्रिंग वापरले, स्प्रिंग कॉम्प्रेस झाले असेल ते पुन्हा रिटर्नला जाईल. एक्सटेन्शन स्ट्रोकच्या टायमाला प्रेशर अप्लाय होऊन जाईल. त्यामुळं तुमचा पिस्टन ह्या पोझिशन पासून इथं येणार पोर्ट वेंट कट आणि नंतर बाय स्प्रिंग युजिंग द बाय स्प्रिंग रिटर्न स्ट्रोकला पुन्हा माघारी जाणार. दिस इज कॉल्ड द न्यूमॅटिक सिंगल ऍक्टिंग सिलेंडर. सिंगल ऍक्टिंग सिलेंडर एकच वर्किंग पोर्ट आहे जिथून आपल्याला प्रेशराइज्ड तुमची एअर पास करू शकतो आणि त्या प्रेशराइज्ड एअर मुळे तुम्हाला फॉरवर्ड मोशन भेटून जाईल तुमच्या पिस्टनला. गेटिंग इट? ओके, आय विल रिपीट वन्स अगेन. Single acting cylinder has a one working port and forward motion of the piston is obtained by supplying compressed air to your working port, and return motion of the piston is obtained by spring which is placed on the rod side of the cylinder. Okay, rod side, this is a rod and this is a side. Okay, rod side of the cylinder spring is placed, and here schematic diagram of this single acting cylinder it is shown. Okay, you can see that. And single acting cylinders are used where force is required to be exerted only in one direction. Please remember, single acting cylinders are used where force is required to be exerted only in one direction. Only in one direction. Okay, such as for where this one direction force is required. Okay, such as application I will tell the clamping, feeding, sorting, locking, ejecting, braking, etc. These are the applications where single acting cylinders are used. Okay, and these single acting cylinders require only about half the air volume consumed by the your double acting cylinder for one operating cycle. Okay, some practical knowledge we should know. So BS standard 578 use preferred size for the cylinder bore and rod diameter of the your metric cylinder. Okay, so this is a practically as per standard that size was you have to choose, and most cylinder manufacturers have based their standard range of metric cylinders on their recommendation. Okay, and once again I'm repeating, most cylinder manufacturers have based their standard range of metric cylinder on these recommendations. Okay, PS 57851980, and offering 2 rod sizes for each cylinder bore. Okay, that is as per the ISO 1219. Okay, whatever the ISO 12191 that gives a symbol for most commonly cylinder in industry, that here they have shown. Okay, this is a single acting cylinder. Here direction control wall is there. Okay, in that direction control 3x2 direction control wall is used. Okay, hand, and that is also hand operated. Here it's a this is symbol. Yet we have not studied in detail due to that maybe some to understand it is some maybe the difficult to understood to you. Okay, it is difficult to understand. Whether my voice is audible, I think. Okay. Whether my voice is audible.
Yes, sir. Audible.
Yes, sir.
Okay. So what are the pneumatic circuit is there now? Sorry, system. So for that purpose, we need the single acting cylinder and the control valve. So here we have to use the direction control valve. In that direction control again, types are there, hand operated 3x2. Okay, 3x2 that I will tell. Okay, here see 3x2 means what? When if you use the port 3, then it is called a 3, and 2 means what? Action, 2 ways. Okay, 2. Okay, in detail we'll go see the after. Okay, see when wall is actuated, then port 2 and 1 is connected and a block, and port 3 is blocked. Okay, okay, just see that. Okay, 3x2 wall direction control is here used. Okay, single acting cylinder. See that their angle they have given. Then we have to give the piston speed also. And that value we have to give same. Values, please remember these values we have to give that time when we are performing the simulation. Bore diameter, how to calculate, and then pneumatic circuit. Okay, you will get the pneumatic circuit like this. Okay, this is pneumatic circuit. This is indirect control of a single acting cylinder. Okay. Getting? So this is the theory part. Let us go for now we'll not we'll go for directly procedure. Now how to perform this practical, that also will go. So procedure is that firstly we need to enter the value of the load. Okay, that you want to transfer in the in load tab. Okay, then after giving the value load, we have to give the value of the angle of inclination on which object is placed in angle. Okay, load, angle, then we have to give the speed, then we have to give the diameter of your cylinder. Okay, then what to submit your answer. And if your calculation is wrong, you will be asked to repeat the same. Okay, then we have to set the direction control valve. Then we have to complete the connection with the working port, supply port and exhaust port, and then we have to run the system. Okay, why I'm taking in fast, because this part once again I'm going to take, because yet we have not finished that control valves and circuit, so it is difficult to understand you this part. Okay, see, this is our circuit diagram. Okay, this is our cylinder. Okay, so, the single acting cylinder, and this is the wall. Okay, direction control valve 3x2, 3 ports and 2 openings. Now here we have for the calculation to calculate the that. So here we have to give the load. Okay, sorry, weight of the load in pounds. We have to give. Suppose I will give the 10. Okay, just randomly I am taking a angle of inclination. I will give 40. Check input. Please enter the answer in numeric. Here I will go 50. Then speed we have to select. Yes. Answer is correct. Okay. Then calculate EPS. I will give EPS value of 60. Air pressure Okay, these are the formula. Okay, now see our angle of inclination. I have taken 40 into the load. Then calculate cylinder area. I will give something value. Okay. We'll give the value 1 meter. Just I am taking the reference value. It just that is opening. Okay, so weight value will take a 400. Okay, then we need to take angle of inclination. Angle of inclination 30 will take. Then calculate the force. Okay, force 200. Then we have to take the Fs. Speed we have to choose a 5. Speed we will take 5. Then Fs we have to calculate Fs 300. Okay, that is also correct. We have to give the air pressure. Air pressure in the psi will take 20. Okay, then cylinder area 15 will take, and diameter cylinder diameter will take 6 here. Okay, and I will submit. Okay, now I will start. See, now you can see the simulation. Once again, I will start. Now you can see. I will reset. See the simulation. This is a practical. Where these values. Okay, and by giving this value, how our that circuit operates or system operates, that we see. Okay. Once again, I will show. Okay, this is our circuit diagram. Okay. Now I will start our simulation. I will click on the on button. See. Fluid, then fluid is passing to this cylinder. That this one of this is your wall duration 3/2 on duration control. This is your single acting cylinder. Okay, after pressure, now this is pressurizing, no? Here what happening here? Action, whatever the mechanical work is producing, also that is producing here, that is obtaining here. Okay, see, getting it? Whether it is interesting? Once again, I will go. Now we'll change the value. Okay, we will change the value. Now instead of 400, we'll take 150 load. Okay, 150 load I have taken. Then I will take angle of attack 10. Then 25. 150. Then speed. Speed I have take 5. This is 38 point value of PFS 38.25. Okay. Then air pressure will take 80 PSI will take. Okay. Sorry, 800 and area 0.05 will take, and diameter 0.3125. 0.3125. Okay, so like this you can take any value, no problem. It's a range we have seen in the theory part. Then what to submit? Okay, now after submitting you have to see correct value, it is correct. So now we have to start, click on the start. After starting, see the circuit diagram completion started. Okay, now we will start this simulation also. I will click on the on button. See, I have operated duration control, all the fluid is passing. It is coming to the your port of the cylinder. See, it is compressed. Okay, that means work happened. Okay, I will click on the off. Then it is returning to the your own original position. Getting it? So this is a simulation part. Okay, that is performance of the practical. Okay, then post test is there. Okay, then references are given. Okay, from where you can take the. Okay, getting it? I will just. Okay, so this was the our virtual practical. Okay, I will show one video now. Whether somewhat understood or not. Second part, the second example was as we have not covered the theory yet. Due to that, it is I think difficult to understand, but let it be. After completion of the our chapter 2, okay, once again we'll take this practical, because that time you will come to know that what is that direction control wall, what is 3x2, everything, and the other cylinders also. Okay, now I will show the one video. 1 minute. Just 1 minute. Okay, how a hydraulic system works, that I will show.
If you have this V shape of hair loss, this may be due to male pattern baldness. In fact, more than 40.
Hello everyone, in today's video lecture we will discuss about components of hydraulic system. इस लेक्चर को शुरू करने से पहले हम थोड़ा सा हाइड्रोलिक सिस्टम के बारे में जानेंगे कि जो हाइड्रोलिक सिस्टम है वो नाम से ही समझ में आ रहा है कि ऐसा सिस्टम जो किसी फ्लूइड पे काम करे, किसी फ्लूइड के माध्यम से वो काम कर रहा हो तो वो हाइड्रोलिक सिस्टम होगा। और इस हाइड्रोलिक सिस्टम को काम करने के लिए हमें कई सारे कंपोनेंट्स की ज़रूरत पड़ती है। ये बेसिक कंपोनेंट्स हैं, इनसे ज़्यादा भी कंपोनेंट्स हम यूज़ कर सकते हैं, बट ये बेसिक कंपोनेंट्स हैं और हम इस वीडियो में वही बात करेंगे कि कौन कौन से कंपोनेंट्स हैं और उनके फंक्शन क्या है और हाइड्रोलिक सिस्टम किस तरीके से काम करेगा। ओके, तो सबसे पहले है फंक्शंस ऑफ कंपोनेंट्स। अगर हम पहले कंपोनेंट की बात करें वो है रिजर्वोयर यानी कि फ्लूइड। इसमें हम क्या करते हैं,
व्हिडिओचा आवाज येतोय का?
Yes, sir.
Or we'll see small video, okay, because we don't have that much time for today's component. One minute, just 1 minute. Okay, we'll see the components. Okay.
In this video, we will discuss about what are the basic components of hydraulic system. So let's start the video. It will help you for the better understanding of hydraulics.
This is not good.
In this video, I discuss is the pressure relief valve. So I discuss the hydraulic systems or component used in a hydraulic systems. So in a hydraulic systems, the various components are used. The basic hydraulic system has the following components. First component is the oil reservoirs. So here we go with the animation so you can easily understand it. So it is the oil reservoirs in which the oil are stored. Okay. Second component is the rotary pumps. So pump is located here and the pump is runs by using this electric motor. So here the M is written and this is the shaft. Okay. So this shaft is transmit the power from motor to pump. The pump take the oil from the oil reservoirs, increase its pressures, and then it is supplied to the direction controls valve. Third component is the pressure relief valve. So pressure relief valve is generally installed at the outlet of the pump because it is generally used for the control the pressure. Okay. So it is installed here, that is called as the pressure relief valve. Fourth one is the direction control valve. So we understand these all the components in the detail later on. First we see the what are the various components. So just we make the list. So here you see it is a 4x2 direction control valves. So it is a 4x2 control valve, means that is a 2 inlet and 2 outlet is there. Total 4 valve is there. Okay. So this is one inlet that is coming out from the pump. It is the P, and it have the 2 outlets. Okay. It is either supplied to this A pipe or either supplied to the B pipe. That's why its name is the 4x2 direction control valve. Then after next is the flow control valve. So flow control valve is provided here. Okay. So here you see it is the flow control valve. The next component is the double acting cylinder.
Already
Here
this type
the
of
double acting
schematic
cylinders.
was,
Why its name is double acting? Because inside the cylinder, here you see this yellow color component is the piston, and the oil is supplying both the side of the piston. That's why it is called as the double acting cylinders. So oil is either supply A sides and a B side. Okay, or it is supplied on both the sides. Next component is the pressure gauge. So pressure gauge is also installed at the outlet of the pump. So here you see it is the pressure gauge. And the last component is the filter. So here you see this is a 4x2 control valve. Okay, so here the 4 valve is provided and its name is the T. Then this oil return is supplied to this filter here. Okay, so this component name is the filter. Okay, in a some book the filter is provided at the inlet of the pump. Okay, in a some book it is provided at the outlet of the pumps. Sorry, not outlet, but it is at the return pipes. Okay, so if you see the filter here,
lot of people don't believe me when I say I was working in a job 3 years ago.
Here at the inlet of the pump, this is also the correct. Now we understand all the component in the details. First component is the oil reservoirs. Okay, so here in this image you see at the bottom the oil reservoir is provided. So main functions of the oil reservoir is to store sufficient amount of the hydraulic oil in the system. Means it is generally used for the storage of the oils. Okay, in a bike or car, what we are doing, we are store the petrol or diesels in our car tanks. So similarly, it is the one of the storage place for the oil, because in a hydraulic systems we know that the liquid is used and generally we are use the oil as a liquids. Okay, and in pneumatic systems we use the air. Apart from this, it has the another important function, such as, means apart from the store of the oil, they have also some another functions. First one is to control the hot return oils. Here you see these are the return oil is coming. So return oil temperature is increased in these various part or various components, because in a pump its pressure is increased. So with this pressure its temperature is also increased due to the friction in these different pipes and then different component, its temperature is also increased. So return oil temperature is higher, so its temperature reduction is also required, and it is carried out in the oil reservoirs. Next function is to settle down the contaminants. So due to the wear and tear, some of the parts are wear out. Okay, so these metal part is coming out with the oils. Okay, so we need to remove this part. It is called as the remove or settle down the contaminants. To remove the air bubbles. Why the air bubble is created in a oil? So when the temperature of the oil is increased, so by default there is possibility of the bubble is created inside the oils. So we need to remove these oil bubbles or air bubbles from the system. Next point is to separate the water from the oil. So it is also carried out in the oil reservoirs. Now before moving ahead, I request to like the video and subscribe my channels for watching the more video related to oil hydraulics and pneumatics and other subject of the mechanical engineerings. For the more video, I request to visit the playlist. Second component is the rotary pump. Okay, so why the rotary pump is required in a oil hydraulic system? We require to increase the pressure. Okay. Without increasing the pressure, oil are not able to create the much force. Okay, so if we increase the pressure, then the force is increased. Okay, the functions of the rotary pump is to pump hydraulic oil to the hydraulic circuits. Means pump is suction the oil from the oil reservoirs, increase its pressures, and this high pressure oil is supplied to this hydraulic circuit. Okay, so these all the part is known as the hydraulic circuit. Means this pressurized oil is supplied to direction control valve, then flow control valves and double acting cylinders. Okay, so this is part is of the shaft. Okay, so in a oil at the constant flow, this pressure is reduced by using this pressure relief valve. Okay, so first the pressure is measured by using directions. Okay, you are going in these directions, you are going into these directions. Okay, so oil is the direction controller suggests to oil to move in these directions. Okay, so
Okay, so, see, whenever we will complete any point, okay, on that point we will are going to see the it's a relevant or related videos animation also that time. Okay, from next lecture, as we have started the actuator part in our theory lecture, so based on that each and every point we are going to see the it's a animation video also for your better understanding purpose. Okay, so don't worry. Okay, because up till now whatever the 8-9 lectures happened, no, so in all lecture, if you see what we have seen the introduction to fluid power, application, advantages, then hydraulic system, pneumatic system, its comparison. We have seen the basic component, and in the last lecture only we have started the our main point, that is the first component of hydraulic system, that is actuator. Okay, in the next lecture we are going to see the first subtype of the component actuator, that is the cylinder linear. For the linear, if you produce the actuator produces linear motion, that time we are calling hydraulic cylinder, that we are going to see. Okay, in that again we have the subtype. Okay, on each type, each category we are going to see it's a animation video. From that you will get the or you will get more information, and it will be easy to understand that concept. Getting it? Okay, so don't think that through only theory and diagram we are not understanding. Okay, I'm going to show that. Okay, don't worry. Okay, for today's practical we will stop here. Okay, you can write your roll number in the chat box, and if you have any doubt, you can ask. You can if you want to ask any problem, you can ask. Any question, issue, you can ask me. All are requested to write your roll number in the chat box as your attendance. Okay, and after writing your attendance, you can leave this meeting, no problem. Thank you. Sujit Mane, roll number 64, Vijay Surve, Rahul Gaikwad, Pratik 65, Prathamesh Patil, Shubham Sungan. Write your roll number and then exit this meeting. Otherwise, if you will not write your roll number, it indicates that you have not attended lecture. Pass.